If you go ahead and visualize the shaded parts of these two graphs after you put them into your calculator, and you keep in mind their constraints. Okay, so these are all the values that are less than or equal to 3x minus 2. So that's shading down this way, below the line. And for the other line, looks something like this. All values are greater than, just greater than. So in actuality, this is a dotted line. But all values for y are above the line. So this is the region of the solution set, and we want a value that's not in there. So you have to be able to visualize that on your graphing calculator, and you'll see or check that 4, 3 lies on the line of this dashed line, but it's not included because of the dashed. So for number 2, if the quadratic formula is used, okay, that's given to you in the back of your Regents booklet, so I'm going to write it up here. X is equal to negative b plus or minus square root b squared minus 4 times a times c all over 2 times a. From this equation, we're going to pull out our a, b, and c. So a is equal to the coefficient of x squared is 1. B is equal to negative 6, the coefficient of x. And c is equal to negative 19, the coefficient of c. Go ahead and substitute in now. So x is equal to negative b, which makes it a positive 6, plus or minus b squared is 36, minus 4 times 1a times c of negative 19, divided by 2 times a, which is 1. This gives us 6 plus or minus square root of 112 all over 2, and that's equal to 16 times 7. So the square root of 16 is 4, radical 7, all divided by 2, and that simplifies to 3 plus or minus 2 radical 7. And the reason why it simplifies to that is because this 2 divides into the 6 3 times, and it divides into the 4 2 times. And that's how we get 3 plus or minus 2 radical 7, and that's choice 1. So for number 3, we're trying to determine which statistic would indicate that a linear function would not be a good fit. So the key term is would not. And as you can see, for this correlation, they would be a good fit. This is a strong negative correlation for number 1, and for choice 2, it's a strong positive correlation. So those two would be good fits. Now when we look at the residual values, the one that is closest to the x-axis is a good fit. Okay, if it were a scatter plot, it would not, but this is the residual value, so we're looking at the differences of the actual points on a line of best fit and the scatter plot. And this choice 4 is a good fit. The one with the pattern is not a good fit. Okay, and this only applies to residual values, so this one would not be a good fit. So for number 4, on the set of axes below, for the restricted domain values between and including negative 6 and 10. So that means for my x and y values in this function, they only want us to graph negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, now you don't have to write all this because all you have to do is put this into the graphing part of your calculator hit Control-T for your table, and it will give you all the outputs here. And then you go ahead and graph it. So as you can see, some of them are not nice points. You get decimals. And I am not expecting you to graph those. Those would kind of by default be graphed when you just plot the nicer looking numbers. So let's find what they are and put those on the graph. So this is a -2. This is a -1. This is a 0. This is a 1. And this is a 2. So let's go ahead and plot those. -6, -2. It's right here. Then we have 1, -1. Right there. 2, 0. Right on the x-axis. If I can get it there. And 3, 1. And 10, 2. There we go. So we get this funky looking graph. And what's important about this is that we graph this as best we can. I don't want to go above this line as we get here within the restricted domain. That's the key or important part here. Okay, so we know that it goes on infinitely in both directions, but we have to follow the instructions with regard to the restricted domain. Okay, so number 5, we want to solve this by factoring. This is a little bit more difficult to do than the other methods that we've used in factoring. So in order to do this, I need to get the 12 to the left side, so we end up with 8m squared plus 20m minus 12 is equal to 0 because we are solving. I can see that I'm going to have a common factor of 4 between each of these coefficients. So I get 2m squared plus 5m minus 3 is equal to 0. And now I'm going to factor the 2m squared plus 5m minus 3. So I get 2m and m. The 3 is going to be here, so it's factors of the last number, 3, or -3. And because I have a plus 5, I need a +3 and a -1. So I'm going to set each one of those equal to 0 and solve. We get m is equal to +1/2 here. And for the second one, m is equal to a -3. So those are my two values for m. Okay, so here's a picture of the parabola that's given for number 6. And it says find the zeros in simplest radical form. So you can't just look at it and say, oh, it lies right here at -3, 0, because it doesn't. It's in between -3, 0 and -2, 0. It's just a little hard to see. It's not close enough. So in order to do that, we're going to have to solve this quadratic. And being that we're missing the middle term, we should be able to set this equal to 0 and solve it without using some sort of method. So I'm going to add the 4 to both sides, and then I'm going to multiply the 2 out. So I get x squared is equal to 8, and if I take the square root of both sides in order to solve for x, because that reverses the process of squaring a number, I get plus or minus 2 radical 2. And those are my zeros in simplest radical form. For this one, number 7, you need to input this into your spreadsheet, into your graphing calculator, and then you're going to write the linear regression equation for this data, where miles driven is the independent variable. So that means that miles driven is your X, and the number of gallons used is your Y. Label the top of your spreadsheet columns, abbreviate where necessary, and then you're going to hit menu 413. And you see your value for M, and they said round to the nearest hundredths place. Make sure you pay attention to that. 0.05x minus 0.92 is your value for B. So for number 8, Max purchased a box of green tea mints. The nutrition label on the box stated that a serving of 3 mints contains a total of 10 calories. On the axis below, graph the function C, where C of x represents the number of calories in x mints. So for every 3 mints, we have 10 calories. So I'm going to label that in my picture. So another 3 is 6, that gives me 20. 10 plus 10 is 20. Another 3 gives me 30. Another 3 after that gives me 12, and then 10 more goes to 40. And then for 15, we go to 50. Okay, we connect the lines with a, connect the dots, with a line. We start from 0. This is going to give me problems, it looks like. I'm doing the best that I can with this. Just doesn't want to cooperate. Okay, so there's my line. Try and make it a little bit better if I can. Okay, that's the best I'm going to be able to get it. So that's the line that represents this. And if I input these coordinates, 310, into the spreadsheet, 620, 930, 1240, 1550, I'll do menu 413 and get linear equation line, and it will also serve as the equation that represents this. And then lastly, a full box of mints contains 180 calories. So if I substitute that in for y into this equation, all I have to do is solve for x to see how many mints would be in the box. So I'm going to multiply the 3 to both sides, divide by 10, and in solving this equation we get 54. So 54 mints. Number 9, David has 2 jobs. He earns $8 per hour babysitting his neighbor's children, and he earns $11 per hour working at the coffee shop. Write an inequality to represent the number of hours X babysitting and the number of hours Y working at the coffee shop that David will need to earn a minimum of $200. David worked 15 hours at the coffee shop. Use the inequality to find the number of full hours he must babysit to reach his goal of $200. So I'm going to let X equal the number of hours that he worked babysitting. And I'm going to use Y, the number of hours he works at the coffee shop. And at that job, he makes $11 an hour. So for babysitting, he makes $8 an hour, and I'm representing the number of hours for babysitting as X. And I'm going to add that to $11 times the number of hours Y that he works at the coffee shop. And he wants to make at least $200, so that's $200 or more. So that's greater than or equal to. So in addition to this, they are telling us that he has worked 15 hours at the coffee shop. That's this information right here. So I'm going to substitute that in for y. And in effect, I'm going to be solving for x, just like as if it were an equation, even though it's an inequality. So I have 8x plus 165 greater than or equal to 200. Solve that inequality, and I get x is greater than or equal to 4.375. That means x has got to be at least 5 hours of babysitting time. Or even 4.5 hours would work. But it says use the inequality to find the number of full hours. So since it says that, I have to go with he must work at least 5 hours. I have to round up. That's the answer. On the set of axes below, graph the function y is equal to the absolute value of x plus 1. All you have to do is put this into your graphing calculator in the graphing portion, click Control-T to get your table of values, and just graph it. Or you can just do this, copy it down here, do the same thing and write the values here. I'm just going to plug it in. Okay, we should see some sort of pattern just from this. Okay, -1, 0, 0, 1, 1, 2, 2, 1, 2, 3. Okay, you should use a straight edge to do this. Never draw lines connecting dots with a straight hand. Okay, now this makes sense. Just theoretically speaking, I know that y is equal to the absolute value of x. Looks something like this. Okay, so this is something we should already know. The vertex is down at the point 0, 0, and 1, 1 is a value, -1, 1 is a value. So it's symmetric with respect to the y-axis. Okay, so it's a v. But when you have inside the function anything added or subtracted to x, that's a horizontal shift. That means I'm taking this picture here and I'm pushing it around as if I could do that physically with my finger. And if you have plus a number, it's going to shift to the left, and if you have minus a number, it's going to shift to the right. So since we have plus 1 inside here, we're going to take this graph and we're moving it over to the left one spot, and as you can see, that's what we did here. Okay, so this is our graph. You could do it either by graphing in the graphing calculator, or you could substitute values in. Okay, so the absolute value of any number is always the positive value because it's the distance away that a number has from x, and that's always positive in distance. Okay, so you could either use the shifting method or you can just actually plot the points. So in stating the range of the function, so the first thing we needed to do was graph, right? That was number 1. Second is to state the range. What are all the y values? So we're starting here and we're looking up here. So as you can see, it goes on to positive infinity, right? So all your values for y are greater than or equal to 0 because we're starting with this point right here. And for number 3, state the domain over which this function is increasing. We're starting here and we're going out this way. So it's increasing, going up towards infinity. So for all your values of x, that's greater than or equal to at -1, because x is at -1 right here.